Okay, now we're recording. Okay, so let's start with number 30, and then we will circle back around and finish the other stuff. Okay, so you're going to have 3 hypothesis test questions on your final exam, but the 3 hypothesis tests are going to be 9 questions because you're going to have 3 questions per test. Okay, so they're splitting it up. So you can guess what kind of questions you're going to have or what kind of tests you're going to have, since there are 3 types. You're going to have one that's sigma known, one that's sigma unknown, and one that's proportion. So first step is going to be, can you identify exactly which question is which type? So that's going to be important. Then these are the 3 questions that are going to be associated with each test. Okay, so it's not going to involve the p-value approach at all. Now, if you remember, we already went through and found some p-value, right? So you did have some p-value problems built in already, like number 27 and number 29, that you had to deal with the p-value. But as far as your actual tests, they're only going to be critical value approach. So I think that's good because I like the little picture. So one question will be find the critical value or values if it's a two-tailed. Find the test statistic. Now, what's the test statistic? That's your observed value, right? That's whether it's Z observed or T observed, right? That's going to be your observed value. And then the result is either going to be reject the null or fail to reject the null. Those are your only options. Well, that's only 2 choices. And since it's multiple choice, they make up 2 other stupid options that you're not going to choose, right? So don't let them fool you. I get every semester, there's somebody that picks one of the stupid choices, and I just want to wring your neck because that's never been an option, right? It's either reject or fail to reject, okay? All right, so I think we are ready to jump right in here. Okay, so we have a company that manufactures ceiling fans, and they claim the fans last an average of 5,500 hours. Well, Lat is fascinated, and he wants to test the hypothesis that the mean life of the fans is less than 5,500 hours. Okay, I think we have an alternative hypothesis right there. Now, we have a sample of 48 that gives a mean life of this with a standard deviation of this. Sorry, it wouldn't come out. Excuse me. And the significance level. Okay, so before we get into writing the test and all that stuff, do we think this is, first of all, I think we can all agree this is not proportion. Everybody comfortable eliminating that? I don't see a percent, I don't see proportion. Okay, good. So is this going to be sigma known or sigma unknown? Unknown. Good. Unknown. Okay, let's talk about why it's unknown. All right, because I do see standard deviation, but what's not in front of it? Population standard deviation. And it's in the same sentence as the sample. It's the sample mean, the sample standard deviation. Everybody got that? Okay, so sigma unknown, perfect. Okay, now let's go through. Let's go ahead and write our null and our alternate. Alternate, yeah, that sounds good to me. Okay, hypothesis. Okay, so we know because it's sigma unknown that it's going to be mu. Okay, all right. Then because I see that he's testing less than, that's going to be the alternate hypothesis or alternative hypothesis, 5,500. There we go. Okay, good. All right, so that means our null is just going to be 50 equals 55. Now, this is not going to be part of the problem, but you still need it, right? Because you need to know what kind of test you have. So what kind of test is this less than test? That's a left tail. All right. Now, we all know that Ms. Holcomb's study guides are suspiciously similar. Okay, this is no exception. So your sigma unknown problem is going to be a left-tailed test. Everybody got it? That's what we're going to practice, is we're going to practice the sigma unknown for the left-tailed test. Good. Okay, so here we go. We have an N of 48. Okay, then this is the sample mean. So that's our X bar, 5,200. Okay, and then this is not sigma. We said sigma's unknown. So what letter is 100 going to be? S. Good. I heard the tiniest little. Okay, good. All right, so if I flip over to my sigma, and oh, and I forgot about the 2.5. So that's alpha. You guys are really good about switching it to a decimal. I got on to college algebra this morning, I can tell you, because they would love to tell me that's 0.25. So remember to move it 2 places over. Okay. Let's see, Landon or what? Okay, so here we go. All right, critical value approach is all we need. We're going to find T observed from the above formula. Ta-da. Okay, and that is going to be our test statistic, is T observed. Okay, first thing we're going to need is S of X bar. So that's 100 over square root of 48. I came up with, I don't have that actually. Sorry guys, I just threw it all in. 14.43. And is that all it gave you? 4.7. Yeah, I like to go out a little bit. Does that look all right? Oh, 3.7. I like to go out if it's the right question. Okay, right number. So I always like to take it out a little bit. Okay, does that sound okay? All right, 14.4337. Okay, so T observed. Now we're going to do X bar minus mu. We're not going to get confused about where mu is. It's the null. And we're going to divide, take that standard deviation out a little bit. Okay, T observed, I came up with 20.785. Okay, everybody okay with that? Negative 20.785. All right, awesome. Okay, let's draw a picture. All right, it's a left-tailed test. So that means one critical value. And what is my critical value going to be? Positive or negative? Negative critical value. Okay, awesome. All right, so if I go back to, oh, and by the way, I only have one alpha, one rejection region. So it's going to be 0.025. All right, so now I'm going to go to my critical value approach. I look at number 2. Number 2 says, find T critical from the T chart using alpha as the area above and using the degrees of freedom. Now, I don't need to multiply anything by 2 or divide anything by 2 because it's not a two-tailed test, right? So I'm just sticking with what I have. So my degrees of freedom are going to be 47. Everybody okay with that? It's just n minus 1. Okay, let's see. Back page. Remember, I have these little packets available out there. So I'm going to find 47. That's my row. My alpha is 0.025, and I go straight across to him, and I see 2.012. Everybody see that? 2.012. Now, there are no negative values on here. We already talked about that. You have to create the negative values if you feel that they should be negative. So we already said, should our critical value be negative? Sure, because it's a left-tailed test. If it's left-tailed, it's negative. If it's right-tailed, it's positive. So believe me when I tell you, you're going to have positive 2.012 is a choice and negative 2.012 is a choice. You're going to have to make sure that you know it's negative. So for your sigma unknown left-tailed, you're going to have a negative critical value, right? Negative critical value. Okay. It's not going to come out that way. You have to do that because of your knowledge of the test. All right. Then all that's left to do is compare. So I'm going to take this T observed over to here. And where does negative 20.785 fall on this number line? Way the heck over here, right? Yeah. So way out here on the left would be your negative 20.785. It's in a shaded region. The shaded region means we're going to reject the null. And there you go. That would be 3 parts to that question. Okay, you want to make sure that you get them all. Sound good? Okay. All right. So there's our sigma unknown. Now, if you want more practice with him, number 34 is also a sigma unknown. Is that right? Yeah. Number 34 is also a sigma unknown. Andrew and Lydia are investigating batteries. So if you want to do that and check it out, you can do that too, okay? And again, look how it's worded. They want to test if it has a shorter lifespan. Shorter lifespan would be left-tailed test. So this is going to be a sigma unknown left-tailed test with a negative critical value. This is perfect practice for you to try again with 34. We're just not going to go through it, but I have it all worked out really nicely, and you can take a picture of it before you leave if you want mine. Okay. All right. So let's skip on over then to 32. Okay. All right. Now we have Maddie. She's claiming that more than 12% of the students in her school do not have reliable internet access at home. I do not have reliable internet access at home. She is worried. To test this claim, she sampled 300 students. 22% of the students in her sample did not have reliable internet access at home. Here's the significance level. Okay, I think this is pretty clear, but what kind of test do we have here? Is it sigma known, unknown, proportion? Yeah. Proportion. This is proportion because we got a whole lot of percents. Does that make sense? So I think that's pretty clear. Okay, we have a lot of different percents, which we are going to have to figure out what in the world are they talking about. Okay, remember, your hypothesis is usually right there in that very first sentence that they're talking about. Okay, so when I go through to try to do these, it's not going to be mu, it's going to be p, right? Proportions have p. Okay, so her claim is that more than 12%, that's going to be your alternative or your alternate hypothesis. So more than is going to be greater than 0.12, which means your null is equal to. Okay, is everybody okay with that? All right, so what we have learned then is on our proportion test, we're going to have a greater than, which is what kind of tail? Right tail. Okay, your proportion is going to be a right tail. That's what we're going to practice for him. Okay, let's go through and name all these other things. She samples 300 students. We know that's in. Okay, from the sample, 22% did not have reliable internet. So that's kind of like your sample mean, but since we have proportion, that's our sample proportion. That's your p hat. So 0.22, that's your p hat. Okay, everybody all right with that? Okay, all right. And then we have an alpha, 0.015. Okay. All right, so if we flip over to the very back page of our little formula packet, that gives us proportion. Okay. So here we go. Notice that on here, here's our Z observed. Here's our standard deviation that's going in the denominator. What kind of Q do I need? Do I need Q hat or plain old Q? Plain old Q. Everybody got that? I need plain old Q. So I'm now going to need a Q. I'm going to do 1 minus 0.12 and I get 0.88. That is not right, is it? Yeah. That's a bit weird. Okay. All right. Here we go. Okay. So first thing we're going to do is we are going to find Z observed. That is our test statistic. Okay. All right. Now to find Z observed, I need sigma P hat. So I'm going to need P times Q over N. Be really careful about what goes in here. Does everybody see that? It is not P hat and Q hat. It is P and Q. Everybody clear? I know that's strange because they call it sigma P hat, so you would think it should be some P hat in there, but it's not. All right. Everybody okay on that? Okay. Let's see. I did not do that either. Anybody got an answer for him? 0.01876. That look good? Okay, great. Thank you. All right. So now I'm going to do P hat minus P divided by that we just found. And I came up with 5.33. Does that sound good? Okay. All right. I'm going to draw my picture. There's my critical value. I don't have to divide alpha. I take them just as is because I have one rejection region. Now, should my critical value be positive or negative? He's over here on the right. Positive. So again, for the proportion, you've got a right-tailed test and a positive critical value. Everybody agree with that? Okay. All right, let's find that critical value then. Okay. So to find Z critical, we're going to use alpha as our area and inverse norm. We do not have a two-tailed test, so we don't have to worry about this. We're going to do inverse norm. .015, 0, 1. Now remember, inverse norm is really designed for areas to the left, and we have thrown in an area to the right. So again, our sign is going to be a little off. You're actually going to get negative 2.17 from this. Is that my critical value? No, it's going to be an option, and it's going to be awfully tempting, but you're going to need to make it positive. To actually be, really correct, instead of putting in 0.015, we should have put in what, 0.085, right? We should have put in the 1 minus this, and that would have given us the positive value. But I feel like it's just one more step, and you guys can figure that out in your head. Okay, then we're ready to test the result. So here's our Z observed, and we're going to see where does he fall on the giant number line. He's over here, right, in rejection area somewhere. So again, we're going to reject the null. Would you believe that I made 6 hypothesis test questions and all 6 reject the null? This is like the worst practice hypothesis test study guide ever. So anywho, that's just a coincidence. All right, what if our T observed had been 1.5? If this had been 1.5, would we reject or fail to reject? Fail to reject. Okay. So every single problem on here is reject. I mean, sorry. Anyhow. Okay. Everybody all right on that? Okay. If you want to practice this guy, one like this, you can go to number 35. Okay. Anna loves animals. She's building a new animal shelter. Okay. This is going to be proportion, right-tailed test, positive critical value. So perfect way to practice one more. And the answer's in the back. You know, I give you a little answer thing in the back, but this would be a good practice for you. All right. Okay, brings us to 33. Okay. All right. So we have a stretch of highway. This one has so much extra information. So we really have to be on our A game here. Okay, stretch of highway where a posted speed limit is 75 miles per hour. Data collected 5 years ago indicate that the average speed of vehicles was actually 73 miles per hour. Okay, that's 3 numbers in one sentence. Let's go ahead and let me just tell you the posted speed limit, who cares? How many years ago? Who cares? You want real data information. That's great that the posted speed limit's 75. Nobody's paying attention to that. You want the average speed of vehicles. That's this, okay? That is going to be your mu. So you're going to get a speeding question, just like this. Stretch a highway, you've got a speed limit, some time has passed, you're going to ignore that. All right, Landon recently found a sample of 35 vehicles that were traveling an average speed of 76 miles per hour. He would like to know whether the average speed of vehicles is now different from 73 miles per hour. Okay, it is known that the population standard deviation is equal to 5 miles per hour and the significance level is 1%. Woo, okay, information overload on this guy. So is this sigma known, unknown, proportion? Perfectly known, right? I mean, it spells it out beautifully right here. So sigma known, fantastic. Okay, is this a left-tailed, a right-tailed, or a two-tailed? It's a two-tailed. How do we know it's a two-tailed? That's a little different, right? This is a two-tailed test. So sigma unknown is left-tailed. Proportion is right-tailed. Sigma known is two-tailed. Okay, we're two-tailed. I don't even have to read anymore. How many critical values am I going to have? 2. I'm going to have 1 positive and 1 negative, and they're going to be exactly the same numbers. 1 positive, 1 negative. Okay. All right. So let's go ahead now and name the rest of our information here. Okay, so we have, oh, actually, sorry, we could go ahead and do our hypotheses. So we're back to mu because proportions is the only one that uses P. All right, so Landon's looking to see if it's different. So not equal to 73, which means your null is 73. Okay, now I see an N of 35. Okay, what is this 76? This average speed of 76? That's X bar, right? Because it's talking about the sample. So that's your sample mean. Okay, and then the only other thing we have is 0.01 for significance level and sigma is 5. Everyone okay with getting all that? All right, we'll jump right in then. This is two-tailed. All right, so test statistic is Z observed. Okay, we flip over to our sigma known page down there at critical value. We're going to need sigma X bar. So we're going to need sigma over square root of 35. I don't have that either. 0.8452. Perfect. Okay, thank you. All right, now I'm going to get Z observed. Okay, he's going to be X bar, 76, minus mu, which is 73, right, over that 0.8452. And I came up with 3.55 for him. Okay. All right, I'm going to draw my picture. This is a two-tailed test. So I'm going to have two of these rejection regions, one in each tail. I'm going to have a negative critical value and a positive critical value. Okay, here's a good place to mess up. Am I going to label both shaded regions of 0.01 for alpha? No, they both have to add to 0.01. So since there's two of them, what am I going to do to my alpha? Divide them by 2. 0.01 divided by 2, and that's 0.005. Be really careful with these tiny decimals. It's not 0.05, right? Make sure that you put that in the calculator. Okay, now to find my Z critical, okay, and I even warn you on here, we're going to use our alpha as the area for inverse norm, but look, if it's a two-tailed test, divide alpha by 2 first. I even put that on here, but hopefully when you draw the picture, it'll jog your memory. So I'm going to do inverse norm 0.00501, and I came out with negative 2.58. Okay, that's one critical value. What's my other critical value? The positive version, right? Okay. Oh, I wrote it in the wrong place. I'm sorry. Okay. All right, last thing we're going to do is take this observed value and bring him over here and see where he falls into things. And I already told you I messed up and rejected every living thing. So he's actually out here, right, in the rejection region, this 3.55. So I'm going to reject the null. What if he had been negative 2.2? Where would negative 2.2 have fallen? Non-rejection, right? And that's what you would put. Okay, good. All right, if you want to check this, if you want to practice this guy, you can go back to 31, number 31. We have Dr. Myers looking at heartbeats, and he's going to be a two-tailed test. He has extra information to cross out in case you want to practice with that. And he, will have your two critical values. He'll be sigma known, okay? Does that sound good? So you have two of each kind of practice, but really they're just exactly alike. Okay. So that would be chapter 9 in a nutshell. So make sure you go back and look at your p-values, how to find those and all that good stuff. All right. Are we ready for chapter 8? Okay. Let's start back at the beginning. Okay. So clear our mind. We're in a different situation now. Okay. So number 1. Okay. What happens to the width of a confidence interval? We're back on confidence intervals, remember? So this is going to be where we take X bar or P hat and we add and subtract a margin of error from it, right? And we get a little parenthesis interval. Okay. So what happens to that interval, the width of the interval, if the confidence level increases? How are they related? Did they do the same thing at the same time, or did they do the opposite thing? Anybody remember that? They do the same thing. Okay, so if the confidence interval, if the confidence level increases, the confidence interval will increase. Whatever happens to one of those, the other one does exactly the same thing. The factor that's the opposite is the sample size. Okay, you don't need to know that. It's not a question, but remember the sample size would do the opposite. Okay, all right, so how are they related? All right, well, when one increases, the other increases. Okay, and then I'm not going to write the second sentence because I'm lazy, but the second sentence would be when one decreases, the other decreases, right? Whatever one does, the other one does, basically. Okay. All right, number 2, when you're making a confidence interval for the population mean using the T procedures, the degrees of freedom for the T distribution are what? How do you get degrees of freedom? What's your formula? N minus 1, good, N minus 1. Now, that is not on your formula sheet. So if that's something you feel like you're gonna forget, that would be something you might wanna add to that, okay? All right, 3 and 4, we're just practicing finding T values. So you're only gonna have one of these, but we're gonna practice it. So we wanna find the value of T. They give you a sample size. They give you a confidence interval. We wanna make sure we can do this. So speaking of formulas not on your formula sheet, we know degrees of freedom are gonna be 19. To find your area, you're going to do 0.5 minus your confidence level divided by 2. That formula is not on your formula sheet. So you're going to want to make sure that you remember this is how you find the area for your T. 0.5 minus your confidence level divided by 2. Remember, your confidence level has to be a decimal. So for this particular problem, my confidence level is going to be 0.98. Okay. All right, that's going to give me an area of 0.01. Okay. So I'm going to go to my T chart. I'm looking at 19 degrees of freedom, 0.01 area, and I get 2.539. Everybody good with that? That's my area, my degrees of freedom, 2.539. That's my T. Okay, let's try it again. All right, I need a degree of freedom for number 4. It's 24, just 25 minus 1. I need an area. It's going to be 0.5 minus 0.90, bless you, over 2. I came up with an area of 0.05 for him. Okay, so now I'm looking at the row 24, the column of 0.05, and I get 1.711. That's my answer. Okay, everybody okay with that? For confidence intervals, that's how you're going to find it. Okay, good. All right, so let's look at 5 and 6 together because they look like they're going to be the same, but they're not. And you need to be able to know the difference in them because they're 2 different formulas. So how large a sample should be selected so the margin of error of estimate for a 95% confidence interval for P is 0.045 when the value of the sample proportion obtained from a preliminary sample is 0.30. I feel like I should be a lawyer to read that. Like that's not even English. And the words are so far away from their corresponding numbers that it's really hard to figure out what the heck they're even talking about. Okay, so I hope you at least got how large a sample. We got how large a sample? Okay, so that means when you see how large a sample and you have your formula sheet, okay, you have 2 choices. All right, here's your chapter 8 formula sheet. You have determining a sample size for mu, and you have determining a sample size for P. Okay, so if sigma's involved, this is your formula. If proportions are involved, this is your formula. Okay, so when I go back and read it here, I see the word proportion. Everybody see that? That means it's got to be this little dude down here. You only have 2 formulas that talk about sample size, and they're right here. This one up top does not have a P in it, and this one down in the bottom does not have a sigma in it. So, I mean, you really can't mix them up. You only have the information for one of them. You just have to figure out what information you have. So, okay, everybody kind of agree then that this is who we're looking for? Is that dude from our formula sheet? Notice the Z is squared, the E is squared, but the P hat and the Q hat are not. They're just wearing hats. Okay, now we have to figure out what in the world. Okay, here's reading comprehension skills. So first of all, I see 95% confidence interval. That gives me Z, okay? That is this guy. Remember this? We can get rid of the middle, and we're gonna take the bigger values for each of these, okay? So for a 95%, my Z is 1.96, okay? All right, got him. Okay, then now if all you're doing is reading the two words before the number, you're gonna think, oh, P is 0.045. Sure, I'll find somewhere to put him. That's not P. In fact, you don't even have a P. So that is the margin of error of estimate for this level for P. This number is your E. That's your margin of error of estimate for P. They just drag it out and put every word they can think of in it. Okay, then I got one more number. The value of the sample proportion. Sample proportion's P hat. Value of the sample proportion obtained from a preliminary sample is, that's that number, okay? And then the only thing we're missing is Q hat, which is gonna be 1 minus P hat, so 0.7 in this case. All right, so that was kind of tricky. Okay, so we're gonna do 1.96 squared times P hat times Q hat all over 0.045 squared. And we're gonna round up to the next whole number, no matter what, and you should get 399. Make sure you round up. I think you actually get 398.4, but you're gonna round it up, right? Okay. Everybody okay with that one? All right, if you wanna practice that one, number 7 would be fantastic practice for this particular formula, but yours is gonna look a lot like number 5, okay? So just be able to identify your numbers. Okay. All right, Case is busy. So he takes heartbeats and he's also interested in this. So he wants to create a 99% confidence interval for the mean of a population whose standard deviation is 10.04. He wants the margin of error to be 3.1. What is the sample size needed? Okay, I do not see the word proportion. Everybody agree with me on that? In fact, I see the words population whose standard deviation is, which means what's 10.04? Sigma, right? So if I go back and compare those two formulas, I have a formula Z squared sigma squared over E squared that I can use. That's the formula for this guy. Okay, I don't have P hat. There's no way for me to even use the other one. Okay, so I have my sigma. How do I find my Z for this guy? It's my percent, right? So if I go to my little Z chart, 99%, we want the bigger number. We want 2.58 for our Z. Okay. And then this one is really clear about your margin of error, thank goodness. He's not as worded as tricky as number 5. Okay, so I'm gonna do 2.58 squared times 10.04 squared divided by 3.1 squared. Everybody's squared in this guy. And I'm gonna round up to a whole number, and you should get 70. Now, I don't have an extra one of these to practice because it's so straightforward. I figured you guys were fine. It's not as weird as the other one. Okay. Everybody okay with that? All right. Okay, we just have 3 more then. Okay. All right, so 7, you could practice if you want, right? He's similar to 5. Okay. All right, here we go. Oh, poor Lydia and Andrew, all of their problems are the extra practice problems. Okay, so number 8. Okay, so Landon determines that a random sample of 82 customers are in who visited a department store spent an average of $71 at this store. Okay, so what is 71? That's our X bar because it's a mean, but it's in the same sentence as the sample. So remember, if it's in the same sentence as the sample, it's your sample mean. Okay, then it outright gives us the population standard deviation, which is fantastic. We know that we're doing sigma. Okay, and we have Z because it gives us the 98% confidence interval. Perfect. 2.33, right off of our little chart, right? That came right off of here for our Z. Okay, so now what we want to find, okay, is, so if we go to our key formulas, here they are, okay, we have sigma is known. Here we go. We have sigma is not known. That's not what we're dealing with. And we have P, right? So this one, this one, this one. Here are your 3 that you're going to want. Confidence interval. Okay, so sigma is known. It tells me that this is what I'm going to deal with. X bar plus or minus Z times sigma X bar, where this is sigma X bar. Okay, so it's right off of here. It's written a little differently than what we've been doing it, but at least you don't have to remember anything. So first, let's find sigma X bar, which is going to be 19 divided by square root of 82. Oh, I do have that. No, I don't. I was lying. Okay. Okay, 2.0982. All right, then I'm going to find my E, which is my Z, which is 2.33 times sigma X bar. I do have that, which is 4.89. And then I'm going to take X bar plus E and X bar minus E. So I'm going to have 71 minus 4.89 and 71 plus 4.89. Okay. Is everybody okay with how we did that? And I came up with 66.11 to 75.89 is my interval. Okay. So find your sigma X bar. It's right there on your key formula sheet. Now it doesn't say that E is Z times that. You don't have to know that if you don't want to, but you find what that is, Z times that number, and then you're going to add it and subtract it from X bar. Is that okay? All right, if you want a little practice with that, practice number 9. It's going to give you sigma. This will help you practice sigma known. Okay. Number 9. Okay, everybody okay with that? All right, 10 and 11 are great practice for 12. Okay, so 10 and 11 are nice practice for 12, but let's do 12 because it's a little more like it. Okay, but 10 and 11 will be good practice. So Andrew took a random sample of 765 persons, which showed that 13.5% do not have any health insurance. Okay, I'm seeing percentages. So what do we think this guy is? Proportions, proportions. Okay, and remember, we can go to our key formula sheet, and here it is right here for our proportion confidence interval. We can find it right here. Okay, all right. So in the same sentence as the sample, it gives me a percent. That's your p hat, 0.135, right? Because p hat is sample, regular p is proportion, or I'm sorry, population. So based on this sample, 95% confidence interval, okay, that's really trying to give me Z. So Z for 95% is 1.96, okay? All right, and then it wants you to make an interval. Okay, so according to our key formula sheet, the first thing we're gonna need to find is our sigma p hat. I think they call it SP hat on there. That's okay. It just means we need p hat, q hat divided by n. Now, I want you to look at that formula that I just wrote. Everybody see that? That's the formula that's on your key formula sheet. That is the formula for proportions for a confidence interval. All right, look guys, we got a problem. Look at this. This is the proportion formula for the confidence interval, the hypothesis test for chapter 9. No wonder students get confused about who's under there. For a confidence interval, it's p hat, q hat. For a hypothesis test, it's PQ. So students get really confused about who's supposed to be under there. And I don't blame you because they're exactly the same, but for two different chapters. So you have to follow the formulas exactly. Hypothesis test is PQ over N, square root. Confidence interval, P hat, Q hat over N, square root. Okay, just wanted to point that out. All right, so I have a P hat, I don't have a Q hat. So 1 minus P hat, that's a strange one to 1 minus, right? He's 0.865. Okay. So I'm going to have 0.135 times 0.865 all over 765. And I'm going to take the square root. And I don't have it. Sorry, Lydia. And my lovely assistant. What'd you get? 0.0. Okay. And then I'm going to take Z times this number. It's going to give me my margin of error. So 1.96 times 0.0124. And I got a margin of error of 0.0242. And then I'm going to do P hat minus, and I'm going to do P hat plus. So when I did P hat minus, I got 0.111, and P hat plus, I got 0.159. Okay. Sorry, I didn't really write that out like I wanted to. I should have said 0.135 plus 0.0242, and I should have said 0.135 minus 0.0242. But that's how I came up with it. Is that okay with everybody? All right, now remember, 10 and 11 are great practice for this if you need it. So for confidence intervals so far, we have done sigma known and we have done proportions. Okay, you can probably guess what 13 is. Maybe you even remember 13 because it's a real pain in the butt. Okay, everybody all right with that 12? Okay, so 13 gives you a list of observations and it tells you, all it tells you is there's 10 of them. Like you couldn't count. I mean, that's not even helpful. And then it wants you to create a confidence interval. This is sigma unknown. This is going to be your sigma unknown confidence interval. You're going to want to use list. You're going to go stat edit and put these in a list because there are two things you're going to have. You're going to have X bar and you're going to have S. Now your calculator is going to call it S of X, but it's not, it's lying. But those are the two things that you're going to need. Okay, so remember, stat edit and put all of these in a list. Okay, so my little recording people, you can't see me, but that's what's happening. I'm just doing stat edit. That gets me my list, right? And I'm going to put all my numbers in there. I guess I should speed it up. 12, 18. Okay, once you get them all in there, you're going to quit. So second mode. Okay, and then we're going to do stat calc 1 bar stats. And then if you have the old school like me, all you're going to put in is L1, and then you're going to hit it. If they give you the other options, what are the fancy options they give you? They give you list and frequency list. Yeah. Is that right? Okay. Your list is L1 and you don't have a frequency list. So you're going to leave it blank. Oh, okay. So everybody okay to get to this point? Everybody got it? Okay, perfect. So then what this gives us is an X bar of 20.1. And it gives us an S of 3.8427. Now I know it says S of X, but we're going to ignore that. Okay, we still are just going to treat this as an S. Everybody okay with that? We're going to take X bar and we're going to take S. That's it. And we already know our N, it's 10. Okay, good. So we have an N of 10. We also have a Z, because it gave us, oh, we can't even use that. Forget, that's not a Z because we're on sigma unknown. My bad. Okay, so this is what we have so far. Okay, let's go to our key formula sheet for chapter 8. All right, sigma is unknown. So here we are, sigma is not known. This means we're gonna find S of X bar, then we're gonna multiply it by T. We don't have a T. We're going to have to go to our T chart and find a T. So what we're going to need to find a T is degrees of freedom, which is going to be 9, and an area. Remember your area. You may want to write this on your key formula sheet, but it's going to be 0.5 minus your confidence level divided by 2. Remember we practiced that. I think it was 3 and 4 on the front or something like that. So I came up with a nice little area of 0.01. Okay. Okay. So if I want to go ahead and find T real quick, I'm going to go degrees of freedom 9, and I'm going to go area 0.01, and I get 2.821. That's going to be my T. Okay. 2.821. Okay, I got distracted. We still need S of X bar, right? So we're going to take our S that we got from our calculator divided by the square root of N. All right, lovely, Lydia. Oh, she's behind. Okay. Okay. All right, my margin of error is going to be T times this 1.2152. And I get a margin of error of 3.4821. I don't know why I took it out so far, but I did. Everyone okay with that? So we found T, and then I found S of X, and then I multiplied them together. That gives you your margin of error. Now you're ready to take your X bar and subtract your margin of error and take your X bar and add your margin of error. And I came up with 16.67 and 23.53. And there we go. And that's how I came up with that. I don't have another one of these that you can practice, but I do have chapter 8 packets left over. And if you have them left over, there's one of these on there in the additional problems that I can give you, or you can look back at that, and that will, and there's plenty on Wiley. I think there's like 4 on Wiley, so knock yourself out. But then that would take care of your test. Okay, so please go through this. If you need extra study guides, take 2 or 3 with you so you can do this, you know, on your own. And then anytime you come across something that makes you pause, or anytime there's a formula that you don't forget, that would be a great way for you, or time for you, to write that on your little test packet that you're going to get to use. And there's more of those back there if you need to take one of those and clean it up nicely. Okay. Anybody have any questions on this? Okay. All right.